My presentation today is titled Extreme Makeover Home Edition. Who here has seen any one of the Extreme Makeover shows on TV? Okay. All right. So at least this won't be new to a lot of people. One of the things that I've realized over probably about the last 7 to 8 years, through some history that I've had an opportunity to work for a company in Raleigh, North Carolina called TogetherSoft, where I had an opportunity to meet a lot of people right at the beginning of a lot of the agile movements and being able to be involved in a lot of XP projects, a lot of Scrum projects, feature-driven development. And one of the things that I've realized is no matter what development processes we ever put into the development teams, there was always this group on the other side of the wall that always gave us there was always a hindrance to there's not enough hardware, there's not enough memory, there's not enough disk. And one of the things that I've recognized is over the last probably 2 months, I've had an opportunity to speak at VMworld in both San Francisco and in Barcelona, and I find it very interesting that here we are at SpringOne, and we still, with everything that's going on with cloud and everything else, we don't have a unified meeting of the minds between what are the IT departments doing from an operations perspective and how do we take advantage of that as developers. You'll see things here with Cloud Foundry, you've got things like Amazon Web Services. IT departments get very concerned when they see us building applications for the cloud because they realize that the data itself may actually be getting moved from outside their four walls. And they get concerned about things like PCI compliance, HIPAA, all of those different types of regulations that we have around data and the way that's being stored. So in this presentation, what I did is I went back through and I looked at kind of a history of where we started with a lot of software development. So for those of you that go back to the mainframe days and building applications, PL1, building things in Kix, and creating green screens, where I can remember the first time I ever worked with somebody, it was amazing to me. My mom was actually, she did data entry for a small hospital where I grew up, and to watch her do all the billing, it was amazing to me. She knew all the keystrokes, she knew everything, she knew all the shortcuts. It's like whenever I see somebody who's really good in VI, it was just amazing. The things she could do by splitting screens, everything else. So in those days when we started off doing that type of development, we basically had a fixed set of hardware that we were working off of. And that hardware that we had, we ended up taking that and just providing a very simple, very modest UI on top of it, but it actually ran from the server. So no matter what things that we ran into, all we had was a screen with a keyboard that basically attached to it, and we did whatever we needed to on the box. So when it came to CPU resources, disk resources, network resources, those things never really came into play because the applications that we built were being optimized. Back in those days, we also had things that whenever you went ahead and you ran a command, if you didn't know what you were doing, you could basically halt everybody. You could basically sit there and hog every CPU on that box, and nobody would ever be any the wiser. So there was never really any fragmentation of how applications got built for that environment. So in traditional extreme makeover sense, we have our family. And our family, we are going to go ahead and look at 15 years ago, the CIO, CTO chose this platform that we're currently building our application on because he lost a bet on the golf course. And now we've got this wonderful infrastructure component, and what they've said is they said this thing costs a lot of money. Therefore, from here on out, everything that we do on this particular box has to live forever. So back when we had the Y2K scare, everybody was saying, oh, you know what, it's time to start moving things off of. Our CIO, our CTO said, nope, got to live with it. We're going to spend millions of dollars to find where those dates are, and we're going to keep this thing running. People kept coming back in, telling them, oh, you know what, you can keep using it. All you have to do is swap out this, swap out that. So over time, what we ran into was the only way that we could ever figure out what the actual costing mechanisms are for these boxes are to use extremely complicated tables. To give you an example, there's an entire website devoted to downloading Excel spreadsheets that you can buy that will tell you how much your MIPS cost. So how do I know how much it costs when I'm building an application for it? What we do is we say, I don't know. We calculate the cost of running an application based on how many developers it's going to take, how many hours it's going to take. So our poor family, they've struggled over the years. The box could perform, but only under certain conditions. The moons had to align, time of day had to be just right, and everything ran smoothly. The other thing that we ran into is the development process was very difficult. So the vendors that sold us these boxes said, no, it's okay, just build on your workstation. We'll give you a container, we'll give you the things that you need, you'll build, and we'll provide you the tooling to package it up, and all you have to do is drop it onto the box, and the box will take care of the rest of it. Project managers love to hear that. So now I go through this process, and now I deploy my application, and basically my spreadsheet for my deployment plan is drop file on box, hit start button. But we all know that's not the way it went. We ran into problems because we had to quiesce the CPUs, we had to quiesce disk, we had to stop networking because we had people that were also using the green screens. There was no guarantee that those users weren't being used. So it was almost like the best thing to do was just to disconnect it from everything, no matter how many users were using it, so I could deploy a new application. So we ran into scenarios over and over with this poor family that the only way they could release an application is they had to create windows in time for deployment in a matter of hours. So it would be a 12-hour window to do a deployment. Oh, and by the way, this window would always be for the wonderful operations team, this is why they love the developers so much, would always be from Saturday at 8 o'clock at night until Sunday morning at 8 a.m. And if everything went right, Sunday at 8 a.m., you got to go home. If not, you were there to fix it until Monday morning, and the CIO or the CTO or the CEO, they were on the phone calling every hour, is it back yet? Is it back yet? So as we went through this process, what I want to do is think about this as the extreme makeover for our applications and for our infrastructure. So we've all built distributed applications. And as we've built these applications, what I want to do is start thinking about how we take this old world. If I had a way, I would love to be able to have a picture right now of having a big mainframe sitting there and having Ty sit there and take his pendulum or take his bulldozer and just roll over it. At some point, you've got to make that break. But I know it's difficult. So from the green screen, what we did is we took our applications and we kind of build on top of them. So it's very much like if you ever did Visual Basic. What happened was somebody would create a little green screen. They'd say, hey, does this look about right? Yeah, that looks right. Push it to production. We don't need any QA. Just go ahead and push it. Well, what about the data on the back end? It doesn't matter. We'll just create separate tables for it. We'll do some munging of the data on the back end. Well, this was a very good model when we had teams of developers that were 5 or 6. And of those 5 or 6 people, one was a PM, one was a product manager, one was QA. So really, when it came down to it, you had 1 or 2 developers. I'm now working on projects where the teams of developers are in the thousands because of work that we've offshored. So with these teams of thousands of people, How do I provide them with an infrastructure? Because I can tell you, can you imagine building green screens with a team of 1,000 people? We got to give each one of them a character. Okay, you put this character here, you tell me which character. So as we're building our applications, we have to go to a new model. So the new model that we came up with from this, as teams started growing, we created our wonderful container and our wonderful EJB. What we could do is we could take our legacy mainframe code, and from that legacy mainframe code, what we could do is we could create a bean. And that bean, we could do a one-to-one mapping between that bean, and then we could expose it. We could expose it to this great new technology called the web. This was also okay, but what happened is we started shifting the paradigm on the mainframe side. What we started running into is we ran into an issue where we started using resources that the mainframe was never meant to optimize. Things like network, things like disk, things like I/O. As we started getting into those issues, we started trying to find an alternative mechanism, because what the vendors would tell us is just take everything and deploy it on the mainframe. That black box in the corner, just deploy everything there, you'll be fine. We know that you'll eat up more MIPS, and the great thing about a mainframe is not only do you pay for the box, but you get to pay every time you use it. So I can remember working in the ECM world and doing enterprise content management, and I can remember sitting down with a vendor once, and they were sitting there saying, oh yeah, it costs, the box itself is $3.5 million, and then every document that goes in, we're going to charge you 18 cents per document that goes in, and every document you pull out, we're going to charge you another 18 cents. And what we'll do is we'll just send you the bill at the end of the quarter, and you can just write us a check. And I was amazed that the CIO said, that sounds like a good model. So as we started going into distributed models, we started realizing that, you know what, we need to find cheaper commoditized hardware to be able to run these applications on. So we got into this wonderful world. We still had everybody who still had the green screens. We still had all of our old data on the mainframe. But what we did is now we had a new, younger CIO that came in, doesn't play golf, he plays tennis. So this particular CIO comes in and decides to put in a bunch of blades or puts in a bunch of rack servers, all commodity-based. The problem is the data. So the mainframe vendor doesn't support a distributed environment. So now we have to create another database. Wonderful. Now I have two databases I need to manage. And what I have is I have data that for my green screens to work, I need certain data on that side. And to make the website work, I need data on that side. So we ended up creating this syncing cycle. Oh, and by the way, now all of a sudden, now that we're using commodity hardware, we now need an HA plan. Because it's commodity, it may break at any point in time. So we've got to have a whole nother site that's completely the same, using the same hardware, because the mainframe never went down, but now to be able to use commodity, we're going to create a DR site. And when we choose our DR site, we're going to choose one of three models. It's going to be a cold standby, a warm standby, or a hot standby. Oh, and by the way, hot standbys are like unicorns. They just don't exist. Okay? So this new world that we're in right now, as we start looking at how the hardware is starting to play out, I can use that same commodity hardware, but I can put a very thin layer on top of it called a hypervisor. And that hypervisor allows me to see all of the hardware on that box as basically a unit of work. It's amazing when I go and I explain that and I go back in, and the CIO who recommended the mainframe 15 years ago goes, that's what we bought 15 years ago. This sounds good. I could create logical partitions. I could go ahead and break up my CPU counts. I could basically dedicate certain pieces of work to a specific CPU. Well, not only can I do that, but I can actually run an entire OS on that particular set of CPU. This is where, going back to what I saw at VMworld, is I remember sitting there in the keynote in San Francisco, and it completely amazed me, because I'm kind of quirky in the way that I actually like going all the way down to the wires and to the network switch and understand how to optimize my applications by understanding what's the IT department actually going to give me. I need to know how many hops this particular network's going to take between my app and my database for me to make sure that the latency isn't too high. I enjoy those kinds of conversations. And there we were sitting in a room of 22,000 people during the keynote, and they're talking about all of the new things that are going on at the hardware level. Everybody's sitting there clapping, yeah, great job, great job. Then all of a sudden they start moving up a layer. They start going above, and they start talking about platform as a service. I swear, half the people got up and left the room. I was like, these are the operations people that are going to be providing the application developers this next wave of how we build applications. And they could care less. We don't care how TC Server runs on that box. We don't care how Oracle runs on this box. We just know that we've got the hardware. We provide you a hypervisor. We give you a RHEL instance or a Windows instance, and we say, here it is. Have at it. Have fun. I don't think that's the right model that we want to go for. So one of the things that I've started realizing is just like when we did agile development, there's now this new wave of people that kind of blend kind of both worlds. They enjoy the operation side, and they also enjoy the development side. So we're falling into this DevOps arena where people actually enjoy taking and tweaking the infrastructure in such a way that I do care how my hypervisor is being configured. I do care how much memory I'm going to give to a VM. I've worked for a client once that walked in, and they said, yeah, we've got a great virtualization strategy. What we do is we take the entire box and we virtualize it. I said, well, how many VMs do you have running on that box? One. Okay. And how much memory is it using? I don't know. How much memory is on the box? It's like, well, why are you doing it? Well, it makes it easy for us to be able to, we can put on a new VMDK and we can put it on that box and we can spin up a new instance. Like, you just don't get it. You don't understand. So as we start thinking about our applications, I think most of us here have built applications, especially if you're using Spring, we have a pattern. We have a pattern for what it looks like. If we're doing SpringMVC and we're talking to a database, we know what that infrastructure looks like. We know that we're going to have a load balancer. We know we're going to have some sort of container. And we know we're going to have a database behind it. Depending on your needs of your application, maybe you're doing Spring for the enterprise. Maybe you're putting Spring and you're using CXF and you're exposing web services. Out of those web services, you're then fronting them with an ESB so people can talk to them. As we take that ESB, we're then taking things like WebSphere MQ or RabbitMQ or ActiveMQ, or maybe we're using something like Camel to be able to pass messages around. There's lots of different ways that we can be using this. What happens is now we can dedicate individual VMs and create a pattern for what an application looks like. We can tell it, oh, my web server doesn't need a lot of memory. Based on that profile that doesn't need a lot of memory, I can create a template for it. So that way, every time when I spin up a new Apache web server, it's always going to look the same. If I'm spinning up a new TC server instance, I can spin it up, I can configure it, I can give it a set of memory options. So one of the things that a lot of people are confused about is when we go from virtualization, dare I say this new word, cloud, people don't really understand. They think of, there's so many different definitions that when I go in and talk to C-level executives about what their definition of cloud is. Cloud to some people is just virtualization. Some people for cloud is anything that I can take that has no business value to it, I'm going to move it to an external data center because that data center costs me money. I've got to run power, I've got to run networking, I've got to have a relationship with my telecom people. It's expensive to run a data center. It's amazing when you walk into the large Fortune 500 companies and you walk through their data centers. And then you go through and you look at some place like Rackspace and you walk through their data centers. It's amazing how similar they are. And I'm like, this has to be expensive. I've got an entire company devoted like Rackspace to build and deploy applications And here I've got a Fortune 500 company that is competing with them. So what pieces can I actually extract out of my application architecture that I could push out to another data center? That's another model of cloud. Other CIOs that I talked to, some of the more progressive C-level executives, had one lady that I worked with who was a CIO. She was actually pushing for doing everything where the VMs themselves. So how many people here remember back, I think it was in the early 2000s, IBM had a great white paper they put together called Autonomic Computing, right? The self-healing server, right? So we're actually getting pretty close to that. It's amazing to me with virtualization, we are actually getting very close that our applications can be self-healing. Imagine if you're running a Tomcat instance, and we all know that the JVM heap, inside that JVM heap, we get to a point where we're at 80% capacity. Well, the last thing I want to have run is garbage collection. I'm taking on the most load I've had in 3 weeks. Don't run garbage collection. So now I can have monitors set up in place that says, oh, you know what, when you get to 60%, I have a template. I have a VM. Go give me another one. Go give me 2 more. I don't care. As long as there's enough hardware underneath it, I can expand and I can contract. What this particular CIO said is, but I don't want to pay for that hardware. So she built a relationship where a dedicated VPN was set up between another data center that they paid for per use, and when they needed more TC server instances, they went to them and said, go spin me up 2 more. I know that I'm always going to have 2 inside my infrastructure that I'm going to run all the time, but when I need to burst, I'm going to burst out into the cloud. So these were things that we could never do at the mainframe. We couldn't sit there and tell the mainframe, oh, you know what, I need a few more CPUs. Let's just go ahead and spin up another mainframe. Okay? This was, bringing in a new mainframe would be a 6-month ordeal. The purchasing and procurement process is a year by itself. So as we start looking at new patterns for how we build applications, as a developer, start to think about what components you want to use. And you start thinking about those things at the architectural level. So as you start to think about things like, are you going to use MongoDB? Maybe you're going to use Neo4j. Maybe you're going to use React. Maybe you're going to use Enterprise DB. Maybe you're going to use MySQL. What technologies can you choose as you're building out your applications that can be templatized? And how many templates do you actually want to create? Now, this is all well and good. vFabric has come along, and they've provided us with something called Application Director, which puts us down the right path. I've got a lot of customers that have gone down the path and built their own equivalents to App Director. Now, as we start to think about, as we're building this new house for our family, and we're providing them new hardware, and we're providing them virtualization, and we're providing them all these great tools, this is now kind of like when you go into the one room and you're sitting there and they've got all these new toys that they can play with, right? These are our new toys that we have to play with in our new IT world for our applications. Now, a lot of people sit there and they say, I really don't care, Lee. This means nothing to me. But it should. If we look at how these applications are built, if we look at the gray boxes around that, that's our base. So what you do is in a virtualized world, I don't go out there and say, I need a new server, go into a rack, put it into the rack, put in the CD, go ahead or download the image from the internet, and go ahead and install on this particular piece of hardware. That's not how we do it anymore. What you're going to do is you're going to create an image, and that image is now clonable. So if you're using anything, if you talk to your IT and your operations folks and you find out that you're using VMware and you're using vCenter and vSphere for your virtualization, common terminology you guys have to get very familiar with to be able to make them, the operations team, feel like you know what you're talking about. Start talking about things like thin provisioning. Start talking about linked clones. What if you were, how many people here do QA? Anybody in here do QA? Nobody? Interesting. So in QA environments, one of the things that we want to do is a lot of times we want to spin up and we want to do performance testing. And we want to basically see the load on a particular application. Well, what if I could tell you that I could create one base image with TC server on it, and I can do what's called a linked clone off of it, and that linked clone is a very thin layer on top of the disk image itself, loads everything into memory, and what it will allow me to do is I can actually run that application using the same disk, using the same VM. So now what happens is as you're doing things where you want to spin up multiple versions of your application, you can do all of that on the fly. So that goes back to here where we're cloning our VMs. So when you get a particular OS image, that OS image can just be cloned and replicated throughout the environment. So, yes. Including the data sources. One of the things that's very interesting is everything is really just a disk image. So when you install, so what database do you guys use? So you use DB2, right? So you have a table space. And that table space gets installed into a particular location, right? So what you can do is you can create your base, right? Your base image. Then what you can do is you can create a separate VMDK, and under vCenter 5.1, that can now be up to 10 terabytes in size, that disk. And what you do is you just mount them. So let's say a new version of DB2 comes along. What would you normally do? Right? You do an in-place upgrade. You cross your fingers that it doesn't corrupt the data, right? So what I can do is I could actually create my base. I could create another, clone it, do the in-place upgrade, and then say, all I'm going to do is disconnect, reattach. Done. I've now done my in-place upgrade. But I've done everything from a virtualized environment. Now, one of the things that's really important is that's a great segue into this next slide, in that now that idea of having a live or a hot DR site, we're now active. Because there's technologies now, because we virtualized everything underneath the hood, what we're able to do is I can take that table space. I don't need to pay IBM or Oracle or whoever I need to be able to do my replication for me at the application layer. I'll do it at the infrastructure level. I'll do a block-by-block copy of that data, and I'll snapshot it every hour. My mean time to recovery now is an hour. If I went into any CIO today and I said, I can give you a hot DR site, and I can give you a mean time to failure of 15 minutes and a mean time to recovery in 1 hour, and I can do it pretty inexpensively, how? When do I get started? But again, we have to start building our applications in a way that take advantage of those technologies. So when we're laying out the VMs themselves, that is important to be working with the operations team. You're going to have to let them know up front, architecturally, how much disk are you going to need? Because everything's running virtualized, they can actually grow and contract that. So I've actually sat down with development teams. It's awesome when we go in and say, well, you know what? All I need is I only need 250 gig right now, but over 5 years, we're going to grow to 5 terabytes. Do you know what that means to an operations team? Oh, I actually can plan my hardware. So I can actually start growing my infrastructure as you grow as an application. So as you start going through, you can actually start adding disks. And as you add disks, you can actually grow those VMs in size. And 10 terabytes right now, to a lot of people on the database side, will sound small. But now imagine as we grow, if you say, oh, I'm going to start off at 10 terabyte now, but in the next 5 years, I'm going to grow to 100. In 5 years, we'll be at 100. It's all in the virtualization. It's all in that hypervisor stack. So what I've started seeing is a pattern around when we're doing virtualization and how we architect our applications. So what you're going to do is everybody's going to have some sort of hardware-based appliance if you're a large enough organization. You have a local traffic manager, and then you're going to have a site. And inside that site, you're going to be broken up into different categories. You're going to have stateful areas, and you're going to have stateless areas. One of the things that I've worked really hard over the last probably 5 or 6 years, is to work with development teams in understanding what parts of their applications are stateful and what parts are stateless. The wonderful way when we started back in early JSPs, when people used to go ahead and say, well, I'm just going to use the application context because it's easy. I don't understand request response. I don't understand how to pass things between pages. That's hard. So now what we need to do is we need to start enforcing those paradigms. We need to start enforcing using Spring and SpringMVC or whatever other MVC technology you want to use, and start setting session context and start setting your request response context and actually passing elements between. I was looking at some code for a friend of mine about 2 weeks ago. They couldn't understand what was going on with their application. It was just, it wouldn't scale. They could not scale in their performance environment. What we found is there was actually a set of code that what they were doing in the web app is they were creating a hash map. And in that hash map, it was a map of maps. And when they went ahead and did that, they were storing that in a request response. And as soon as they went and they put another TC server instance in to try to scale out, the map was gone. Of course the map's gone. I'm not replicating that map across. So now we need to start figuring out where that state's actually being stored. So there are technologies that have evolved that they are complex. They're new to a lot of organizations. But if anybody here who's used EH-cache, if you've used coherence, if you've used Gemfire, if you've used any of these different technologies, you really need to start looking at how to leverage them more for when you're building your applications for this virtualized environment. So as you go through, we've got our stateless web app at the top. Then what we're going to do is we're going to have some sort of transient state. That state may be things like an in-memory data grid, like Gemfire. It could be for my session. But I have to get that out of the web app itself. How many people here know what it means to do sticky session? Right? Why do we do sticky sessions? Because of the hash map example, right? I need to make sure that that user, when they're coming back in, they're always going to get the same server, because if they put something into the map, they better make sure they get the map back. What happens if that server dies? Great user experience. I'm sorry, you were just about to purchase $10 million worth of stuff from our company store. You're going to have to start all over again. So now we need to move that state. We need to move that state into a separate layer. Very easy to do with virtualization. Again, it's all in memory. So if I'm going to create an in-memory data grid for session or for any other type of data I want to store that's transient, so you could set your session. So my session's set to 30 minutes inside of Tomcat TC server. I can go ahead, that's a transient data store. At the end of 30 minutes, what do I want it to do? I want it to evict it. I want to get rid of it. Take it out of the memory. If I go ahead and I get a huge set of users that all of a sudden want to connect, I can just take a snapshot of that template and clone it. Put 3 more in if I wanted to. Now I get that memory times 3. Okay? Or additive by 3. The next layer underneath that's going to be your services. So behind those services, whether they be SOAP or REST, those services then will usually talk to your actual database. The piece that I'm starting to see more and more people doing is, because of that whole master data management thing that we ran into with mainframes, I'm starting to see a shift where probably about 4 years ago, that was a 50-50. 50% of the data was in the mainframe. 50% of the data was on the mid-range. And we were replicating data back and forth to make sure that both applications are running effectively. Now with things like Hadoop and MongoDB and the big data players, what we're doing is we're starting to see some of that start to shift more and more to the mid-range. Because with like Hadoop, if I need to spin up additional Hadoop clusters, same type of thing. VMware has something, if you haven't taken a look at it, called Serengeti. Serengeti is really cool from an operations perspective. It does that scenario where you have DB2 in the table spaces. It does the same thing for Hadoop. So what I do is my Hadoop data on the back end will actually grow and shrink with me as multiple disk images. And what I can do is I can grow and shrink the actual nodes on the front end that allow me to be able to connect to them. So if I'm running end of quarter reporting, what would I do? I spin up a whole bunch of processing nodes. As soon as I'm done, I can shut them down. On the data side, as I'm going ahead and growing and shrinking the data that I'm trying to collect, I can do that as well. So we have a persistent state on the back end. Now this persistent state could be anything. This could be your message queue. This could be your database. This could be a NoSQL database. Whatever it is, it's something that's going to be stored long term. As we started cleaning up data from the mainframe, one of the things that we used to have to do is a lot of us fell into this paradigm because we saw the data already in the database. We actually stored the state of our applications in the database. So what we would do is we would put in there active user. Right? That's a state of that particular user. There are certain things that we want to store long term, but it's not necessarily the state. Usually what we store into the database, we want to segment these things into what is business critical data and what is data that might be maintaining state. I've worked with some really good DBAs over the years that really understand that, and that helps me break up the table spaces in this type of environment. Because my state that may be persistent is now a relationship to the actual business tables, and those business tables I can control. So over here on the left, what we have is the things that we need to virtualize the most. So for the stateless web apps, the thing that we're going to virtualize the most is memory. Sorry. For the transient state, so Gemfire, grid gain, coherence, they support multiple different models. So if you're doing things like PCI or HIPAA, things that, although they're transient in nature, you still need to have some sort of log of what the activity was, and you need to be able to recreate at any particular point in time. That's another thing that your operations folks, as you're starting to learn terminology, anybody here run VMware Workstation or VMware Fusion on their machines? A few people? You guys understand the benefits of creating snapshots, right? Oh, you know what? Just like if you're using Git, right? Let me go ahead, and I'm just going to go ahead and pull a little bit of code over here off to the side. I'm going to do some work. Oh, it worked. Great. I'll stash it. I'll pull it back in. Same idea, but I can do it for the entire VM. So I could go ahead and say, you know what? Let me go ahead and change my database design, and I'm going to change my data. I'm going to run it, and I'm going to see how it reacts. Oh, it didn't react well. Revert snapshot. I'm back to where it was before. So all of the different components that we're going to need to be able to virtualize are all on the left-hand side. Now, one of the things that a lot of people get concerned about is when you're doing virtualization, I/O is the most difficult thing to be able to virtualize. So as you're starting to think about how your applications are going to perform, it is in your best interest to expand horizontally rather than vertically, because you need to spread that I/O across multiple machines. So places where I've gone in and I've talked to directors and senior level management talking about this type of paradigm is, it's hilarious when I said, oh, well, I only need 2 of those. No, that's for representation purposes. That might be 200 in your environment. But we need to do the calculation. It is much better for me because I can spin these up very quickly. It's in my interest to create a 1 gig TC server rather than a TC server running 32 gig of memory. Because of I/O issues, I can spread that I/O across 200 TC server instances all running 1 gig. And using things like local traffic managers and things like that actually allow me to be able to make it very easy to be able to provision these. Now, when we actually look at Application Director, one of the most difficult things that we have when we deploy applications is the dependencies between components. So I have a database that I need to talk to. I've got WebSphere I need to talk to. I've got Gemfire I need to set up. I've got TC Server I need to set up. Application Director actually will manage all of those components for you. Now, when you actually do a deployment from inside of Application Director, or if you decide to build your own, there are very easy ways to do this. Application Director is built on top of the APIs that you all can build your own if it doesn't meet your needs. There's another tool at the core level called Orchestrator that everybody gets with vCenter. Orchestrator is a very cool tool because what it will allow you to do is, oh, that's where I can hook Hyperic in, and all of a sudden I see my VM running out of heap. So what I do is I go ahead and spin up another one. That's what Orchestrator can do for you. But it's very important to have these templates down. Now, the little green objects inside, that's my platform. So inside of the Duke's example that they published with Application Director, the Duke's application basically is going to show you an Apache load balancer, JBoss application server, and then it's using SQL Server 2008. So Application Director is not vFabric only. This is for any environment that you need. The other thing you can do is you can also script it yourself as well. You can create your own deployables. You can create your own, when you pull things in, you have your virtualized environment set up, and you're basically doing imports into it. And then you're basically, this is all drag and drop. You basically say, oh, I need a RHEL server here. Oh, and I want to put JBoss on top of it. Oh, and I need to put my application, I need to deploy my ear in on top of JBoss. And what it does is it runs scripts in the back end to stitch everything together. This allows us as developers to be able to focus in on our code rather than worrying about coding around operations and coding around the issues that we might see in the infrastructure. So now we take that time and move it back into actually providing business value for our customers. Now, the piece that App Director actually talks to is it'll talk to different environments, but the one that's configured for out of the box is called VCloud Director. Now, one of the things that I see a lot of organizations struggle with is when we do development, we have groups of release engineers. So these release engineers, we build our applications, and our applications are built in such a way that we take our application, we use Maven, we use Gradle, we use Ivy, we use whatever. We create a deployable unit. We create a WAR, we create an ear, we create a jar, maybe we create an RPM, maybe we create a gem, whatever we're going to use to deploy. Now, what we do is if I've got multiple environments, what we used to do is we used to have shared database on the back end. So if we're using Oracle or DB2, we'd have a shared database on the back end. Then our application team would basically rack their own servers, and we'd have different racks of servers for each environment. So you'd have dev, you'd have QA, you'd have stage, you'd have production. And what we do is we re-provision in every area. So what happens is once we're done with dev, we sit there and we say, oh, it worked in dev, right? So then we go ahead and we promote it to the next environment. One of the great things I love is when you work in really large organizations and you've got a QA team, and the QA team goes ahead and they find a bug. First thing my developers say, worked in dev. I can't recreate it. I go back to the dev servers, I can't recreate it. Must be something in their environment. What if we could eliminate that finger pointing? With this particular type of setup, with a VApp, inside of a VApp is just a grouping of VMs. So if we go back to that paradigm where we have a pattern of what our deployable units are going to look like for our particular application. So I have 2 MongoDB servers, I've got 1 Enterprise DB server, I've got 1 TC server instance, I've got 3 Gemfire servers, and I've got 2 Apache load balancers on the front end. That's my app. I'm done. I could actually create that inside of App Director and say, this is my app. These are all of the components I need. Now, when I deploy that as a VApp and I deploy that into the environment and I go into Dev, I can actually play around with that in Dev. Let's say there's certain tweaks I want to make to a config. That's where I can go ahead and I can create a linked clone. When you create a linked clone, it actually creates you a thin layer on top. You can make changes to that layer on top, and if you like the changes, you can actually merge it back together. That's actually now part of your VApp. So as you've had to make tweaks and changes. Well, now what? Now what do I do? Now I've gone ahead and I've deployed my application. So what a lot of organizations will do is they'll say, okay, it's time to reprovision and redeploy in the next environment. Why? It's just a VM. It's just a set of disk images. You can actually go in and take the entire VApp, right-click, clone, vMotion to another cluster. That other cluster is where my QA environment is going to be. My VApp's now moved over. It is the exact same VM that I used in Dev. There's no changes. Now I can basically build, and now that goes over to QA. Guess what? QA finds a bug. Oh, found a bug. We got to do a fix. What do I do to my VApp in Dev? I destroy it. Because I have a template, I can recreate it very quickly. So I destroy it, I do a fix, I can redeploy everything into that VApp, and then I go ahead, I seal it up, I vMotion, I move it to another cluster. QA goes ahead and runs it. Oh, everything looks good. Great. Seal all of the VMs, I take all of that, I move it into the next environment. Now, one of the things that a lot of people don't take enough use of is all of the metadata about all of these VMs. There's also metadata around the VApp. That metadata around the VApp, so if you've got something like, so you got an environmental setting, right? So my environmental setting says, where is my Postgres server? I could actually put that in. It's just a set of key value stores. A lot of people will tell me as they say, yeah, but I need something that will be up all the time. Well, I got some bad news for you. If your VApp's down, your app's down. So I might as well run it in the VApp. I might as well put all my environmental settings in the VApp. Because now I can use the APIs on boot up. There's actually things that you can do with Puppet or Chef that you can tell your operations departments. They can actually reach into the VApp's metadata, and when you're actually spinning up a VM, actually populate those things just like I would with a properties file with a property context listener inside of Spring. Except instead of pulling it from a property file, I'll pull it from the metadata of the VApp. If it needs to change, I can go in and change it inside the metadata, and the next time whatever configuration management tool you use, the next hour that it runs to validate, it'll go back and check and say, oh, the metadata's changed, rechange it, and go ahead and change the environment settings. But now we get out of having to have multiple servers across each environment. The other thing that I can do is, let's say Data Center East is overburdened, but Data Center West is really light. I could actually take that entire VApp from East and move it to the West data center. Doesn't matter to me. All of my stuff, it's in a VApp. It's all self-contained. It even has its own networking. It's got its own virtual switch. Yes?
No issues going like a remote interface call outside the VApp?
So what I've done with people when you need VApps to talk to other VApps, it's just like if I was going between multiple data centers, right? So usually that's where I will expose a service. And what would happen is you could put, like in this diagram, how you've got the VApp network, you could actually put down on the VLAN, the prod VLAN underneath, you could actually switch that over and actually put an ESB at that layer. So everybody talks to your ESB or to Camel or to Spring Integration, whatever you want to use. So the other thing is if you don't want to have something like that and you do want VApps to talk to other VApps, then you're going to configure it that they all use the same virtual switch, just like you would in your environment. if you need to go and you need to segment them, let's say one of the VApps, you can use profiles. That one VApp needs PCI compliance. I can actually segment them, and what I can do is I can actually use something called vShield Edge. And vShield Edge will actually route me to that VM when I make a request. Okay. Okay. So here on the left-hand side of VCloud Director, one of the things, I actually went back to VMware and I asked them, I said, for development teams that are using vFabric, what I would love to see them do is they've got organizations, then they've got virtual data centers inside of organizations. I'm like, just give me a properties file. Give me an I18N properties file so I can just change those names. Because it would be so easy to sell this particular product to customers if all I did was I changed it to environment and application. Now what happens is people would understand that when I create a virtual data center, I'm actually creating a new environment for my applications. My VApps then live inside the application layer, and I can create virtual applications inside of that. And I can actually build this tree of where all of my components live. Now, one of the things that we have to do is we now need to get more diligent about how we build our applications as well. So now we have this fancy new, right? So this is my, if anybody here has watched the Home Edition, Extreme Makeover Home Edition, this is my peanut butter and jelly scenario, right? So we've now built our house. We've now moved the bus. We've now shown the people, here is your brand new shiny house. Now we want to take advantage of it. So as we're building out our applications, we need to make sure that we're segmenting our applications and we're building them in a way that they can all be deployed as individual units. This is where I tell you ears are bad. Okay? So if you're deploying to something like JBoss or to WebSphere, deploying ears are a necessary evil, but we group so much information together. I worked for an organization once that our ear was 636 meg in size. Like, my deployable application is 600, well, it's all the jar dependencies. Okay. So that's great. So I've got 636 meg, I got to deploy this server. So if that's just my ear, I'm scared to see how much memory this thing's going to take when it actually starts. Okay? So we need to start thinking. This is where I think frameworks like Spring are so valuable to this environment because it needs to be really lightweight and we really need to shrink our applications down. This is where we need to take all of our applications, they need to go on a diet. My friends who all work in the agile world hate me for saying this, but when I've taken people into this world, it has not been oh, well, let's go in and let's refactor our code and let's create our unit tests and let's make sure everything works. This is where I walk away and say, old project goes in directory A, new application exists in B. So what I'm going to do is I'm actually going to break up my application. A lot of applications that I build in this way, so right here I'm just using IntelliJ, and on the left-hand side, I've got 3 different projects. A lot of places that I've worked in, I've actually got this where it could be 10 or 15. Depends on my deployable units. Each one of my projects usually equates to a VM, usually a template. So I know that this particular project, when I go ahead and I run Maven or Gradle, whatever, that deployable unit that's going to come from there is going to go into something like Jenkins or Hudson, and that's now going to be something that I can reach out over HTTP and I can pull it down onto the server. But it has to be broken up into small units of work. You have to segment them. So now we really need to get good at, logical mappings between components. So one of the things that I was very happy to see, I guess it was last year, Gemfire getting acquired by VMware. I'm actually a former Gemstone employee back in the late 90s. So I love the Gemfire technology. I've worked with Coherence. I've worked with IBM's Grid Appliance. They all pretty much do the same thing, but Gemfire is the only one that can be optimized to run on a virtual machine. So you can tune it, you can tweak it. It works very well inside of VMs, and it scales very well horizontally. Now, when we actually look at how we build these applications, what we have is very simple SpringMVC apps. So here I got a very simple, what we did is we created something called Petfire, which is our JPET store with Gemfire. So if you see NanoTrader this week, this was our own version to be able to test and tweak Gemfire for our environment. Now, inside of the Petfire web application, it creates its WAR. Now, the WAR itself is very powerful as a deployable unit, but at the same time, I need Gemfire on the back end. So for Gemfire, what we did is we created what we call a Spring bootloader. So there's actually a project from Apache called Apache Commons Daemon, which is actually used by Tomcat when it actually starts up, Tomcat. So we used it to actually start up Gemfire, because Gemfire by itself has a vast set of APIs. If you don't know which API to call, you could get lost quickly. So what we did is we wrapped it in Spring, so what we'd be able to use is use Spring Data Gemfire out of the box. So we're using a combination for Gemfire. We have all of our resources. Now, this cache XML, the cache XML basically defines our cache. We have two different layers. One of the things that we want to be able to do is this particular jar that we create out of here, I need to be able to take and drop onto a box and run standalone. Well, how do I do that? I've got to run java-jar, or I can run Apache Commons Daemon. I've got to have a bash script that starts it up. Those are the kinds of things that go into those templates. So now what I do is I'm building as, if I think about that wrapper, about that VM, this is my deployable unit that's going to go into that. So when I actually run it, it needs to be able to run automatically. And it needs to be able to run whether a developer in project team A or developer in project team Z, whatever gets built out of here has to be able to run on both VMs just as easily. I'm no longer creating one-offs for every environment. That should all be metadata driven. My application should just be my application. Why should I have to build an application and say, oh, I'm going to go ahead and configure in here my Spring config. I'm going to tell it I need 64 gig of memory. Really? On my local machine? I'm going to tell it I need, well, I'm sorry, I only have 8. So why would I tell it I need 64? So that's all metadata driven. So you're going to pull those things in. You're going to use things like Spring profiles. You're going to say for local dev, I only need 2 gig of memory, or I only need 500 meg of memory. But then what I'm going to do is that Spring profile, when I actually boot it up and I run it off the VApp, the VApp's going to go ahead and say, oh, where's the metadata for which profile I'm running in? Oh, I'm looking at the VDC. My virtual data center is actually QA, and in the QA environment, it says I need 64 gig of memory. That's where I pull in my property from. Okay? So one of the things I was very happy about this week is for about the last 6 months, as they've been building out Spring Data Gemfire, one of the things that they've been doing is they've been creating wrappers around the ways to be able to programmatically create what is called a region. So regions are where we actually serialize our objects. So before, what we had to do is not all of the properties were set. So we would actually have to create a Spring Bean like this. This is a joy to do, right? Go grab the Java doc, go look at all the setters, and go ahead and create an instance of the bean, and then go ahead and set all of them using properties. So now what they've done is, to make things easier, the new Spring Data Gemfire 1.2.0 release that just came out this week, that whole thing now becomes this. Okay? Now inside, as you start thinking about how you're going to grow horizontally, inside of Gemfire, there's two different models. I have replicated, I have replicated regions, and I have partitioned regions. So replicated regions are exactly what they mean. All the data in node A is going to be replicated in node B, is going to be replicated in node C. Partition regions are really kind of cool because what they do is they create an internal hash map of knowing how many of a particular object exists in any one of the other servers. So inside of here we have total number of buckets, and we say how many copies do I want. So I'm going to make sure that my data, if I've got 5 servers out there, Gemfire is automatically going to make sure that there's 1 copy. So I can lose an entire node, and I always have a copy of the data that I can rebuild off of one of the other servers. So it makes sure that the data is always on 2 servers. Now you can bump that up. You could say 3, depending on how many you're going to have. Now, the other thing that Gemfire gives us is, as we are talking about that HA environment, that active-active model, there's another component inside of Gemfire called the WAN gateway. Now, the WAN gateway in 7.0 will be going away, but this gives us a transient data store that can span wide area networks. And the wide area networks are not like, oh, so where's this been tested? Oh, so you've gone from Washington, D.C. to Baltimore. Congratulations, right? This is going from London to Singapore. That's the type of wide area network we're talking about. Customers, when we actually demo Gemfire on site, and then we actually get it deployed into their WAN configurations, when we tell them, they say, well, how long will it take to replicate an object? And we say, well, the architectural answer, well, it depends. It depends on how large your objects are, and it depends on the latency between the different data centers. Now, with the WAN gateways, it's usually the easiest way to calculate is 3 times ping. So if you ping data center from data center 1 to data center 2, and your ping time is 20 milliseconds, your replication of any object is going to be 60 milliseconds. It's pretty quick. So one of the things that's really funny is when we go through and people are saying, like, we use this a lot for session, right, for HTTP session. Now, imagine never having to do sticky sessions ever again. And not only that, I can fail over between data centers. I could actually reroute a user because there's a whole bunch of traffic in east. I can reroute that user to west, and I could actually do it between page loads. So I could be doing SpringMVC, and I could do a request response object that I stick into the session. I can actually go to another data center and pick up where I left off. It's pretty powerful. So again, this all goes back to I've got to be able to have that house. I've got to be able to have that infrastructure that it's able to support that as well. If you do this in physical hardware, you'll pull your hair out. Because Gemfire is one of those things that wants to expand and contract very quickly. It's going to want you to create 2 more nodes. It's going to want you to subtract nodes. It really is a cloud-enabled technology. Now, can you imagine calling up on a Friday night at like 10 o'clock? Hey, Bob, yeah, we're going to need 4 more Gemfire servers racked tonight. We're going to expand tonight. Call them up Saturday afternoon at noon. Hey, Bob, can you take 2 of those servers out? They're going to go nuts, right? So what we end up doing is, unfortunately, a lot of times we end up going towards our high water mark, towards our threshold. And we'll say, the operations people will say, just tell us, how many do you think you ever need? I don't know. I'll need 20. Great, we'll just buy you 20 and be done. But then over the course, those servers are plugged in, they're consuming power, and that's where virtualization has come in because we've tried to take that away by being able to make these servers where we're using them at 80% CPU utilization instead of at 2% utilization. Okay, getting more bang for our buck. Now, when I run this actually will have a region that we create for our pets, which the other thing that's not in here is now one of the really nice things is this is just like an L2 cache. So if I needed to, I could go in here and do a GFE. I can do a cache loader, or I can do a cache writer. So what I could do is, let's say you've got on your web page, how many people here load static content onto a web page for a drop-down, right? That's reused over and over and over again. What I can do is I can actually pull that out that when Gemfire spins up, I'll actually go into a select into the database, go and get that data, and I'll actually put it in. And then what will happen is hopefully it will hit the cache before it ever goes to the database. Why? Because the only thing my database should be doing is storing business-related data. But because we have persistent data that we're using for lookup tables and things like that, we store them in the database. I can actually put them into Gemfire. Okay? Now, the other thing you can do is you can have a cache writer. Now, one of the really nice things is most other technologies, their cache writers are only JDBC compliant, especially on the Java side. So when you do a cache writer, their cache writers all extend off of some component of JDBC, or you have to integrate them with Hibernate, right? Hibernate or MyBetas, or you have to integrate them with some sort of OR technology. The nice thing about Gemfire's cache writer is it could be anything. I could do a cache writer. I could persist it to ActiveMQ or to RabbitMQ. I could do a cache writer. I could go ahead and persist it to a web service that's exposed from Salesforce. So I could cache everything in front of my CRM that I'm using for all of my internal customers. So you can do these cache loaders and cache writers. You can call whatever you want. It's just Java code. So kind of put one of those in. If you're interested in learning more about that, I can talk about that later. The other thing that I've done is inside of here we have a backup. So the backup, whenever I go ahead and write anything to memory, I also write it to disk. Now, down at the bottom here, we have a region time to live. So with this region time to live, what I'm going to do is I'm going to destroy it. Now, I have a timeout. My timeout is set to 0. That's the default. Timeout of 0 does not mean that as soon as I put it, it's going to destroy it. What timeout of 0 means is it's actually going to be looking for a value inside of, let's see, inside of here. I have what is called a resource manager. And what my resource manager does is it looks and says, what is my critical heap percentage? And my heap percentage is 80%. And then what I'm going to do is I'm going to set an eviction heap percentage that basically says whenever it gets to 75% of heap allocation, I'm going to start evicting elements, right? So it's the oldest one in is going to be the first one evicted. What I'll do is I'll start flushing stuff out of the cache until such time that it can recover and get lower than that 75%. This process runs continuously. So again, as we start thinking about that transient layer across our VMs, these are the kinds of things we want to make sure is baked into the technology. Because we don't want to have to worry about these things. We want these things to automatically, that autonomic computing type model. I want them to automatically heal themselves. This resource manager can also trigger an event. So I could pass this event off to Hyperic. I could pass this event off to my operations tool, whatever that may be. So when I actually run this, so this is just a main method inside. So inside of here, I just have a main method that basically calls my Spring bootloader, which is just loading from my application context. So here I'm loading my Gemfire context in. So when I run this, I am now on my local machine, I am now running Gemfire. Gemfire is now up and running on my local box. Very easy setup. Now, one of the things that I've done is this is also Maven enabled. Oh, I think I just ran it twice. That one's going to tell me the port's already being used. So inside my Palm, what I'm doing is I'm just going through and doing everything again. But now what I'm doing is I'm setting it up so it will create a jar. That jar is now executable. So what I'm seeing inside of IntelliJ is the exact same thing that I would see on the VM. Okay? That's the model that you need to get into. Whatever is running on your local machine, surrounded in that environment. One of the other things that I'm starting to see some customers even pick up on as well is especially places that do BYOD, bring your own device to work. What they're doing is their development environment is actually coming as a VM. So I can use whatever tool I want to be able to write my code in. I could use STS, I could use NetBeans, I could use IntelliJ, my license, personal license. I'm using it for work. however you want to interpret that license. What will happen is when you deploy, you actually deploy to a pre-configured VM. It's almost like having your own little vApp running on your machine. So what I can do is I can deploy my database. I can deploy all those components I'm now testing, and I have the same type of utilities that I would have as if I was running in the operations environment. Now I hear so many developers that will tell me, and they'll say, well, I really wish I could have the dev environment running on my local machine. We can actually do that now. With enough hardware on your laptop, you can actually do it. I've done it at home as well. I've got a little Mac Mini running at home, and I ran a bare metal hypervisor on it, and I can spin up to 5 VMs up on that box. I've got my own little dev environment running on my Mac Mini at home. Cost me $300. Okay, so lots of different ways of being able to. The funny thing is, I even take my Mac Mini; it even travels with me. So when I go to the hotel room, I plug it in. I can actually connect to it. So I actually have my own dev environment that goes with me. So again, being able to deploy and create those little units of work and being able to deploy them out in the environment. Now that I have my bootloaders running, so now what I can do is inside of my TC server, now, those of you that are used to using IntelliJ, if you're using TC Server, two things you need to know. One is there's an updated plugin for TC Server that was released about 2 weeks ago that finally works with TC Server 2.7 and TC Server 2.8. The other thing is the deployment only works through JMX. So what you have to do is inside when you actually create off of a template, when you actually create a TC server instance, you have to go into the JMX remote password, and I changed mine to be super secure. And then what you have to do is inside the TC server config, you have to give it JMX authentication enabled, and you have to give it the username and password. If you do that, it'll then deploy your applications. At least, I hope it deployed it. Let's see here. Oh, of course, whenever you're given a demo, it never works. Let me make sure this guy didn't screw something up. So we can see here the server connection. So we can see that it's actually coming from a local host. We can actually see that our TC server is connecting to it. I also have the HTTP session module plugged in as well, which is just another download. You plug it in, and then what happens, you can do client server mode, which then TC server will talk to a remote Gemfire grid, and then all of your sessions will basically go out into that transient data store. Let's see if that'll work. Nope. I had made a small change. Let me go back and put the change back. Yay. Okay. So now from inside of here, what I'm going to do is I'm going to do an add. And let's add a new goldfish. Our goldfish are expensive. Whole economy and everything. Okay. So here we actually have something that's talking to the session. So I can see I added one product in the session. And now I've actually got an element that's actually in a separate region that's just in the pet region. Now, if everything works properly, here we can see that our cache listener, we can see that in our region, our pet region, that what we did is we actually serialized a pet object. And that pet object got serialized, and there we have our category, which came back. We've got our goldfish, SpringOne, goldfish, and our price. That's all in there. And let's see. And here we can see that the Gemfire module session is throwing errors, which basically says it tried to put something in there. But our redundancy is set to 1, but I only have one server. So I can't replicate, it can't put a copy of that on another server for me. So it's throwing me a warning saying you should add more servers because we can't guarantee that if the server goes down that the data won't be lost. Now, with the persistence enabled, I could actually stop this. These are the kinds of things, as we start thinking about VMs, we start thinking about where our transient and our persistent storage is going to be. What I'm going to do is I'm going to stop both of these. And then start them again. Now, our session should be empty, right? Because I stopped TC server. So here I see, back to the beginning, there's no products in this session, but due to the persistence, my goldfish is still there. Okay? Now you can play around with things like the LRU, the least recently used. You can play with the TTL. Then you play with your cache writers and your cache loaders, and you put your database behind that. Maybe that's a web service call. Maybe that's a database call, whatever it may be. Now what happens is you start to create those layers in between. And so you could take this particular layer where you just have TC server, Gemfire at a top layer, talking to something else that would be TC server talking to a database on the back end. So you could even simplify it in such a point that you've got stateless talking to transient, stateless talking to persistent, and those two models, and then you can even break up your development teams. I've seen it be very effective when I break those two up, that I can have one group building off the components talking to the database where storing business-related values and business-related data, and then I can take the other team and have them doing SpringMVC on the other side using Gemfire. But now with the cache loaders, right, if I'm doing something where I'm doing local testing, I could do a cache loader and I could read from an Excel file. Or I could read from a comma-separated value file. I don't need the database behind it. I don't need the services behind it for me to start building out my web pages. So I can actually separate the two of them. Then I do an integration test when the two of them are ready, and I pull the two of them. Any questions? I know it's Thursday. They gave me a great time slot right before lunch on Thursday. Everybody's ready to go home. Well, great. Well, thank you all very much for coming.